Hi everyone, today we are going to start the Enolate chemistry, and in this chapter we are going to discuss these reactions. The very first one is Aldol condensation, second one is a Claisen condensation, third one is a Dickman condensation, fourth one is a Michael addition, then Robinson annulation, haloform reaction and Maloney ester synthesis. Aldol is basically three types: self, crossed and intramolecular. So let's start the very first one. What is basically enolate is, so look at here. Enolate is composed of two words, which is enol plus ate. Ate means negative charge on oxygen, negative charge on oxygen. And enol is what? En plus all, en plus all. En means carbon double bond carbon. All means when you have OH group. Clear? So simply we can say when OH is directly bonded to carbon double bond carbon called as enol. Example: you can see in these three examples, here OH is bonded to double bond, here bonded to double bond carbon, and here OH is bonded to a double bond carbon. So they are enol. And what is enolate? Enolate means if you are going to remove the hydrogen of enol, suppose this one, and this one. So this is the enolate, the removal of hydrogen from enol form. Okay. So let me discuss the formation of enolate. Suppose you have aldehyde, suppose this one, and we have a base. Suppose OH minus is a base, and this carbon is called alpha carbon. What is alpha carbon? The neighboring carbon bonded to carbonyl group. So this is the carbonyl bond, and the neighboring carbon is the alpha carbon. So base has a tendency to grab the acidic hydrogen, and this hydrogen is very acidic. So this OH will grab this hydrogen. So there we have a negative charge on the alpha carbon, this one. This is now in resonance. I discussed how to draw the resonance structure. So it will donate and it break like this. So here we have this compound CH2 double bond C, O minus and H. Clear? So this is called enolate. So in enolate chemistry we have this intermediate. Clear? Suppose you have this one. This is alpha and have a 2 hydrogen. We have a base. So base will grab this hydrogen. So now negative on a carbon. Now this is in resonance, so it will donate the electron and CO breaks like this. So we have a negative on the oxygen. Like this. And this is my enolate. Clear? Let's talk about the very first reaction, which is called aldol condensation. I am going to start the very first one, which is called self-aldol condensation. Self-aldol condensation. So here we have few conditions in self-aldol. Let me discuss the condition. The very first condition is 2 same mole of aldehyde and ketone. So 2 same mole of aldehyde or ketone. Okay. The second condition is they must have at least one alpha H. Must have at least one alpha H. So let me discuss what is alpha H and all. So look at here the example. This is compound A. This one is my compound B. This one is a compound C. This one is a compound D. This one is a compound E. And this one is my F. So here we have to find out which of the following compound we can use as a reactant in self-aldol condensation. And the condition is very clear, must have at least one alpha H. So first of all, what is alpha H? So look at here, this is methyl, okay. So carbonyl neighboring carbon is called alpha carbon, the direct neighboring, the very first neighbor. So either this or this, both are alpha. This one is a my carbonyl and this one is same, right or left alpha. This one is a carbonyl, so this carbon is my alpha. This one is my carbonyl, so this carbon is my alpha. And this one is a carbonyl, but there is no neighboring carbon, so no alpha carbon. And this one is my carbonyl, so this carbon is my alpha carbon. I said that, look at my word, I said that carbonyl carbon must have at least one alpha H. One alpha H. What is alpha H? Alpha H is a hydrogen of alpha carbon. Here we have alpha carbon and that has hydrogen, so it can give aldol condensation, the self-aldol condensation. This alpha carbon also have a hydrogen once you balance this, so it can give self-aldol condensation. This carbonyl has this carbon as alpha, but there is no hydrogen on this alpha carbon. You can see all the bonds are the carbon, no hydrogen, so it cannot be my self-aldol reactant, means it cannot give self-aldol because this is methyl, and this one is also methyl. But this carbon has no hydrogen, means alpha hydrogen is here 0. Alpha H is 0. This one also the same, alpha carbon has no hydrogen. There is no alpha carbon. This is the alpha carbon and there is a hydrogen. So it can give, clear? So this is about the condition, means we can use these kind of reactant in the self-aldol. Now what is the reaction? Suppose we have 2 same mole of this aldehyde and we are going to treat them with a base called OH minus. So what is the mechanism? So look at here. First mole, which is my CH3CHO. OH minus is a base, so it will grab the alpha hydrogen, this alpha H. So here we have a negative charge on a carbon. It is now in resonance, so it can form its resonance structure as well, and I am going to draw like this. CH2 double bond CO minus H. This is enolate, okay. So these two are the resonance structure. We all knew there is a carbon negative and we have an oxygen negative. Which one is a better nucleophile? So if you look at the nucleophilicity, I told you negative charge is basically on oxygen and here carbon. Which one is more electronegative in nature? Oxygen. So nucleophilicity is a tendency to donate electron and electronegativity is a tendency to grab electron. So carbon negative is a good donor one. So it will donate better, while oxygen negative is not such a good donor. So carbon negative is a stronger nucleophile. So we will use this one as a nucleophile, okay, not the enolate one. If you want to react from enolate, then you have to do something different like this. It will revert the electron and then double bond is going to attack, something like that. The arrow must be in this way. While here, this is my nucleophile and we know that we have 2 mole of this aldehyde. So 1 mole is used to make a nucleophile and now we have a second mole. This one CH3CHO. We all knew there is a reaction called nucleophilic addition, which means nucleophile attacks on the carbonyl carbon, and this is the carbonyl carbon we have, and this one is a nucleophile, so it attacks like this and this bond is going to break. So look at the product here, CH3O minus CO minus, we have H, and now I am going to attach this part, so CH2 CHO. So we have water as well in the reaction. Why? Because OH minus grabs this hydrogen, so it becomes water. So we can use the water molecule, and we all knew this oxygen negative is going to grab this proton, so it becomes OH. So CH3 CH OH CH2 CHO. This type of chemical compound is called as the carbonyl neighboring is alpha, alpha neighboring is beta. So this one has aldehyde as well as alcohol, aldehyde as well as alcohol. So this is called aldol, aldol. And chemically it is called as beta hydroxycarbonyl, beta hydroxycarbonyl. Clear? This is beta hydroxycarbonyl. And once you are going to heat this, there is a loss of water molecule. Okay. So once you are going to heat this, we can remove the water molecule. So my product will be, there is a double bond between alpha beta. So product will be this CH3, CH double bond CH, CHO. This one is a final product and this is called alpha beta. We have a double bond here, so called as alpha beta unsaturated carbonyl, alpha beta unsaturated carbonyl. Clear? So this is the final product of aldol condensation. So first mole is used to generate a nucleophile. Then another mole is my aldehyde and ketone, because we have 2 same mole, and this step is called nucleophilic addition. The very first step is the acid base reaction, because base grabs the hydrogen of this alpha carbon. So this is acid base. The second one is the nucleophilic addition, and the third one is a condensation. Okay. So whenever you have this CH3CHO and here we have a heat, so you have to directly form the final product. Clear? This one. We can discuss another example. So look at here with mechanism. Suppose we have this 2 mole and we are using OH minus as a base and heat. So what should be my final product? So look at the mechanism. We have this carbonyl, this is my alpha carbon, have a 2 hydrogen. So base will grab this one. So here we have a negative charge. So 1 mole is used to generate the nucleophile. Now the second mole, the same mole of aldehyde and ketone, this one. We all knew reaction will be nucleophilic addition, so it attack over here and it will break like that. So it should be in this way. And you know, after H2O, oxygen minus grabs this proton, so it becomes OH. It will be OH like this. This is my aldol. because this is alpha, this is beta hydroxycarbonyl. And once you are going to heat this, if you are going to heat this, there is a double bond between them. This is alpha beta unsaturated compound carbonyl, which is my final product. So this is the mechanism of aldol condensation. So sometimes it can be a question from the mechanism as well, and there is a trick as well. We can directly draw the final product as well as aldol. So let me discuss that one. Suppose we have 2 mole of this aldehyde. So look at here. 1 mole we will write in such a way where we can show our oxygen bond like this, in this way. And second mole we should write in such a way we can show our alpha hydrogen one. So this is my alpha carbon, so this one is my alpha H. Clear? Now simply you have to remove water molecule, so oxygen and 2 hydrogen. So there is a loss of water, and you can attach directly CH3 CH double bond CH CHO. So this is my final product. Suppose you have to draw the aldol one. So first you can draw the final product and then aldol. So aldol is what? Aldol is my beta hydroxycarbonyl. This is alpha, this is beta. So whenever you have to draw aldol, just attach a water molecule, means OH on the beta and hydrogen on the alpha. Simple. Because beta hydroxy is my aldol, so keep OH at beta carbon. Look at here. This is alpha, this is beta. I said that keep OH at beta and hydrogen at alpha. So it becomes CH2. So this is my beta hydroxycarbonyl, which is aldol. Clear? So this is self aldol. We can discuss another example. Suppose this one. So 1 mole you can write in such a way where you can show the oxygen connectivity like this, and 1 mole in such a way where you can show the alpha hydrogen like this. And now eliminate the water molecule and connect them. So you can see this is alpha beta unsaturated, which is my final product. And if you want to generate the aldol, we know that it should be beta hydroxycarbonyl. So we can attach beta hydroxy, which means OH at beta position. So this is alpha, this is beta, so keep OH at beta. Simple. Clear? So this is all about the self-aldol condensation. This is the trick. Second one is my crossed aldol. So crossed aldol means the condition number 1, 2 different mole of aldehyde and ketone. 2 different mole of aldehyde and ketone. And second thing, anyone or both must have alpha H. Must have alpha H. Look at the example. I am not going to discuss the mechanism. I am just going to teach you the direct method. Suppose we have 1 mole at CHO, another mole suppose CH3CHO. And my question is, what should be the product of this reaction? So you can see we have 2 mole and both are different this time. So this is crossed aldol, and you have to first figure out which of the following has alpha hydrogen. Both mole we have, so which one has alpha H? Yes, this one has alpha. So suppose you have 1 mole of carbonyl where no alpha hydrogen, so you can remove its oxygen part, and another mole where we have alpha H, so you can remove its alpha hydrogen. So this side we can remove its oxygen, so we can draw like this. This side we have alpha, so you can remove the alpha hydrogen. So there is a loss of water molecule. So the product will be CH2 double bond CH and then CHO. So this is alpha beta unsaturated, which is my final product, and we know that we can make the aldol as well. Aldol is called beta hydroxy carbonyl. So this is beta, so CH2OH, beta hydroxy CH2 and then CHO. This is aldol. Clear? Sometimes we have a product and we have to figure out its reactant part. This is called retroaldol, like this. This one. We all knew this is alpha beta unsaturated. You can see alpha beta unsaturated, which is my final product. And we have to find out what is my reactant. So look at the trick here. Suppose you have aldol. This one is my aldol. Why this one is aldol? Because we know that the beta hydroxy is my aldol, so this is aldol. So sometimes it can be from aldol or final product as well, both. So what should be my reactant? So look at the very simple one. Once you have a final product, then it will be easy from the final one. If you have aldol, then convert them into the final product. How can we convert? Just remove water from alpha and beta, means you have to remove the beta hydroxy and alpha hydrogen, keep a double bond. Then this is final product. So simple thing is that whenever you have a final product which is my alpha beta unsaturated, so break the alpha beta double bond. You have to break alpha beta double bond like this. Break this one. Now look at this is alpha beta double bond. So once you break this, now you have to add OH group. Which group? OH group. Only OH. One side oxygen, another side hydrogen. So look at here. This side already have oxygen, CO bond. So we are not going to add oxygen in the alpha carbon side. You have to add hydrogen on the alpha carbon side, and beta side has oxygen. So we are going to add a double bond oxygen here and a hydrogen here. Clear? Makes sense? Again listen me. I said we are going to add oxygen and hydrogen. Beta has oxygen and alpha has hydrogen. And one more thing, you have to add 2 hydrogen here, because we all knew whenever carbon is in the terminal position, it should be CH3, not CH2. So if you want to balance this, you should add a 2 hydrogen. Clear? Like this. So my reactant will be CH3CHO. Sorry, CH3CO, CH3, 1 mole, and second mole is again CH3, C double bond OH. This is my 2 mole of this. Clear? Makes sense? Alpha side 2 hydrogen, beta side oxygen, means overall you have to attach water molecule. 2 and 1. Beta side oxygen, alpha side 2 hydrogen. This is the most easy way. Second question, suppose we have this one. Okay, suppose we can do this one. This one, suppose. I am going to remove this. Suppose we have this carbonyl bond. We have this final product, okay, and we have to figure out what is my reactant. What is my reactant? So first of all, you have to mark alpha beta carbon. We all knew carbonyl neighboring carbon is alpha, alpha neighboring is beta. So I said that break this bond. Alpha side you have to add 2 hydrogen and beta side just oxygen. So here we have a double bond oxygen and here you have 2 hydrogen, 1H, 1H. So my product will be, the reactant will be like this, double bond O plus C double bond O, and here you have 2 hydrogen. There is no need to show the hydrogen because it is well understood. This is bond line form. So here we have 2 hydrogen. So these two are my reactant part. Clear? So this is called retroaldol as well. Retro means product to reactant. Now the third one is intramolecular. This one. So look at the important point. In intramolecular aldol, we have two aldehyde molecule in a same compound. Self two same mole of aldehyde, but not in a same compound. Okay. Intra means 2 mole of aldehyde in a same compound, in a same chain, or even you can say. And crossed means 2 different mole of carbonyl. Okay. So look at the very first thing. If you want to draw the product directly, the best way is what? Remove one side of aldehyde to alpha hydrogen, and one side of aldehyde you can remove its oxygen. So first of all, we can mark the numbering here. 1, 2, 3, 4, 5, 6, 7. Clear? So you can keep both aldehyde and ketone quite same to each other like this. 1, 2, 3, 4, 5, 6, 7. C double bond OH, C double bond OH like this. Makes sense? I used in this way, the cyclic form. Now look at the trick here. I said that one side you have to remove the alpha and second side you can remove its oxygen, the carbonyl oxygen. So I can draw this one in such a way. Look at here. Like this. You can say numbering here, 7 carbon member ring. 1, 2, 3, 4, 5, 6, 7. This is supposed to be my alpha where we have 2 hydrogen. Now you have to remove this water molecule, water. Clear? You have to remove this CO and this H. So there is a bond between. We can do the numbering as well. Suppose we have this carbon as my 1, the ring 1 I am talking about. So 1, 2, 3, 4, 5 and 6. So you can make 6 member ring like this. Suppose this is 1, this is 2, this is 3, this is 4, this is 5 and this is 6. You know that 1 directly bonded to 6 by a double bond because there is a loss of water molecule. So 1 to 6 is a double bond. And you can see 1 has a outside carbonyl. 1 has a outside carbonyl. So 1 has C double bond OH like this. So you can see this is alpha, this is beta. Alpha, beta, unsaturated carbonyl. Clear? If you are getting confused about this is 7 member, why this one is a 6 member. So simple thing is that you can always start numbering from the alpha carbon, the very first alpha carbon to the ring like this. It will give you an idea the number of carbon in the ring. Suppose 1, 2, 3, 4, 5 and this is 6. So simply you can remove the oxygen part of it and 2 alpha hydrogen of this. And keep a double bond between 1 to 6. Clear? Simple. Suppose we have another reaction like this. This one. So I said that alpha, suppose here we have some groups like dimethyl. So we have to start the numbering from the alpha carbon to the another mole of carbonyl. So this is my alpha supposed to be, and you can say this one as 1, 2, 3, 4, 5. Clear? We all knew alpha has 2 hydrogen. So there is a loss of water molecule from this oxygen to this alpha. So there is a 5-member ring, 1 and this 5. So 5-member carbon containing ring in which 1 directly bonded to 5, like this. This is 5-member ring, suppose 1, 2, 3, 4, 5. And you can start numbering from any position, it doesn't matter. Suppose you are going to start numbering like this. Suppose this is my 1, this is 2, this is 3, this is 4, this is 5. Now look at the connectivity. 1 directly bonded to 5 by a double bond. So 1 and 5 have a double bond, 1 and 5 have a double bond. Number 3 carbon has a dimethyl group. Number 3 carbon has a dimethyl group. And number 1 has a CHO group which is outside the ring, because 1 has a carbon which is CHO. So 1 is this one and this is CHO. So makes sense. This one is my alpha, this one is a beta. So there is a alpha beta unsaturated carbonyl which is intramolecular aldol. In the next session we will discuss the Claisen condensation, Dickman condensation. So thank you so much for watching this. Please share and subscribe.